Hey guys, we're kind of starting statistics, just a quick intro and some of the topics that you'll end up seeing, especially right at the beginning of statistics. So before I started, I wanted to kind of talk about why is stats different from your other math classes. You've probably heard your friends talk about why it looks different, but here are a couple of the main things I think that would make it look super different than any of the other math classes you've taken. First of all, there's a lot of writing in statistics. A lot of it is calculating a number and then figuring out what it means in context. So you have to know a lot of vocabulary. You do have to write a lot. That's one of the reasons I never wanted to teach statistics whenever it was offered to me, because I'd have to grade like essays almost, and I was like, um, you get to use your calculator the whole time. No one's going to take your calculator away from you because it is mostly interpretation. So if you know how to interpret the number, then you just have to be able to get the number, which is why they let you use your calculator. And then, of course, there's a lot of applications to the real world, and because it's all about context in statistics. So it's going to look a lot different than other math classes that you've taken. It's a really useful class, don't get me wrong. It's just something that you kind of have to change your mindset. So with that, let's start. We're going to talk a little bit about some things that you may know, but with some different notations. Again, this is all about vocabulary. So today we're talking about measures of center, and we're trying to calculate the measures of center for quantitative data. What that means, quantitative, it just means numbers. Instead of talking about like observations like colors or something like that, we have number data. I don't know. I don't know the difference anymore. So the two big vocabulary words that we're talking about today are statistic and parameter. Statistic is a number that describes a sample. That's like a small thing. You're sampling part of the population. Whereas the parameter is the number that describes an entire population. So it does the entire whatever, the world, whatever. We're not able to calculate the parameter all the time. Most of the times we're going to be dealing with statistics because they measure a sample, and we're able to take a sample much easier than obviously sampling the whole world. Okay, so the first thing, the sample mean. We're going to calculate the sample mean. Remember, the mean is just the average of something. So in order to find the average, you add up all of the observations, and then you divide by the number of observations. And that's all that this formula is saying. Right here, this crazy, whatever you want to call it, is just saying add up all the numbers, divide by the number of numbers. So let's talk about what all of these little pieces mean. This right here, this X with a line over the top, we call that X bar, at least that's what I've always called it, and that is what we call the sample mean. So if you see a letter with a line over it, it's just the sample mean, okay? Then the next little symbol you see is that big sigma. We talked about that a long time ago, we think in the binomial unit, and that just means the summation. So to find a summation, you add up all the numbers. So with that, after the summation, we have an x sub I, and all that means is each observation. So it's saying add up each observation, so add up each piece of your set, and then divide by the number of observations or the sample size. Okay, so again, all that this is saying right here is to add all the observations up, add up the numbers, and then divide by the number of numbers. Whoa, sorry, a cat's jumping on my back. So again, that's all that this weird notation means. I'm not telling you to calculate the sample mean or calculate the mean any differently than you've always done. It's just adding a couple new Greek letters and stuff in. So if we have something like this first example, it says a random selection of numbered tiles was chosen. Calculate the mean of the sample using the formula above, and then interpret the mean in context. So you're going to see a lot of stuff like this. Interpret the mean in context. So the first thing we need to do is find the mean, and then we're going to interpret whatever that is. So in order to find the mean, the sample mean, we're going to take every single observation and add them together. 9 plus 4 plus 11 plus 13. And then I'm going to divide by the number of observations there were. So 1, 2, 3, 4, 5, 6. Okay. Again, type this in your calculator. Please don't try to do this in your head. Once I type this in my calculator, I get that the answer is 7.33. We're going to round to 2 decimals unless they ask me someplace else. And then again, they asked me to find the context. So I put this cute little thing. This is context cat. So you remember to always find your context. So in order for me to talk about this particular number I found, because otherwise it's just 7.33. Well, what does that mean? In context, it means on average, a random selection of tiles has a value of 7.33. So because I pulled that many tiles out, the average number I would find on any of those tiles is 7.33. So again, writing your answer in words is an important part of all of this statistical analysis. Okay. The next measure of center we're going to talk about is median. Okay, you learned about median way back in the day. Mean, median, mode, range, all those things. These are not anything different. We're just putting some more technical stuff on it. So we're calculating the median, and again, the median is the middle. It's like the middle of the road, that weird thing where all the grass is when you're driving. That's called a median. So calculating the median, the first thing you have to do if you're doing this by hand is you have to arrange all the values in order from smallest to largest. So if your set's not in order, you have to reorder it and make sure it's from smallest to largest. So after that, if the number of values in the set is odd, so if you had 3, 5, 7, however many values in your set, the median is just the middle value. So if there were 3 numbers in your data set, the very middle of that would be 2. Pretty straightforward. It's just the center value. It gets a little more tricky when you have an even number of data points. There we go. We're going to take the average of the 2 center values. So again, if you have an even number of values in your data set, find the 2 middle values and then take the average of them. So add them up and divide by 2. So the one thing that's kind of nice, there's a little formula that we can use to find the location of the median. Again, this is the location of the median, not the actual median. It's just telling me what number would my median point be. So if I'm trying to say, if I had a data set of like 300 numbers and I wanted to know what place would my median be, this is how I can find it. If I take the number of observations, so the number in my set, add 1, and then divide by 2, that's going to tell me the location. Where is it? It's not the actual median. It's just telling me where could I find it if I'm looking for it and I don't want to have to try to count it all out. Okay, so again, the first thing I'm going to do if I'm trying to calculate the median of the data set is I'm going to rearrange my numbers. And again, this is probably the most time-consuming part where you have to sort your data. So if I sort this, my lowest is 2, and I always forget 1 eventually. So 4, that's why I cross them out. 4, 7, and whoa, my thing froze. 10. Okay, so I've reordered them, great. And now if I want to figure out where the location of my mean is going to be, what number point is it going to be, I'm going to take however many are in my set, 1, 2, 3, 4, 5, 6, add 1, divide by 2. So that's 7 over 2, or it's in the 3.5 spot. Okay, the 3.5 spot kind of lets me see that I'm going to have to do some averaging in the middle here. So again, it's an even number of data points. I don't know how to say these vocabulary words apparently. So I'm going to pick the middle 2 values. Again, there's 2 on either side. One of the things that kind of helps me is sometimes I'll like cross out the ones on the edges evenly until I get to the middle and see what happens. So I'm going to take these 2 values and average them together. I know that seems silly, but if it wasn't nice, I would have to do that. So 4 plus 4 over 2 is 8 over 2 is 4 still. So my median of this set is 4. Again, if we're looking for context of this, the median of the data set is 4. You're going to have to write words out. It's not just as simple as necessarily finding a number and circling it and moving on. We have to talk about the median of the data set is 4 because some other things about the data could also be 4. So we want to make sure we're specific and we provide context. I don't know if you can hear the cat meowing in the background. Okay, the last thing we're going to talk about measures of center is transforming your data. So if you transform your data, that just means they're going to tell you, you need to either change this one data point, or maybe you need to add or subtract to something the whole way. Like maybe we accidentally mismeasured and we need to add 1 to every data number, whatever. If you transform all of your values by adding or subtracting a constant, you will add or subtract that constant to all measures of center and location. Okay, we'll talk about variation and standard deviation tomorrow, But if you're adding or subtracting a constant, you're just going to add it to each value. Okay, same thing for multiplying. If you're going to multiply every single point by a number, then that's also going to multiply any of your measures of center, location, and in this case also spread. Okay, so let's look at an example. It's kind of weird to think about. So if I am given this particular example, it says given the x bar, so the average, the mean, is that what happens to the mean when you add 5 to each data value. Okay, surprise, this was the example we did in the beginning. So if I took this example data set and I added 5 to each value, so I'm going to add 5, and I'm probably going to do this wrong just because I know I will. So 6, 11, 14, 9, 16, 18. Okay, so if I have this new data set, I've added 5 to every single point, and I went and found the mean of that. So if I add up all the points, again, I used my calculator, I got 74. 74 over 6 is 12.33. So if we compare the old mean, I'm going to say old mean, it was 7.3, and then the new mean is 12.33, whatever. You notice here that all I did was add 5 to the mean, which makes sense. All of my values changed by that same number. So that means that my measures of central whatever measure, I just said that totally wrong, would also add 5. So for this case, your new mean, when you're adding or subtracting something to every single value, is going to be your old mean, maybe, I can't write now, plus whatever it was. So in this case, my x bar new, my new mean is 12.3. Okay, so the same thing's going to happen if I multiply everything in that data set. Just think about it. If you multiplied every single thing by 3, and we knew what the median was to begin with, that median is also just going to multiply by 3. Okay, unless you're changing just a single point, they're all going to change by the same amount. So given that the median of a set of data is 3, what happens to the median when you multiply each value by 2? So in this case, we're going to find my new median. It's going to be my old median and multiply that by 2. So my old median was 3. I'm multiplying it by 2. So surprise, that's 6. So my new median, I'm just going to write med. I don't have a lot of space. My med new is equal to 6. Okay, so again, when you transform your data, just look at it, try to get a set of example data if you need to, and actually do what they said. So add 5, multiply by 2, whatever. Okay, and that is all I've got for you about the beginning of statistics.